Hello folks. So today I'm going to share you something which I've built, and it's kind of an MVP. It's not fully fledged but a minimal viable product which I've built, and which is called NeuroStash. This is what I've built, and what this is about, let me share you in this video. This is kind of introductory video about what I'm going to build. So NeuroStash is something, an end-to-end API solution. So basically we are building an API solution for smaller enterprises. This solution is for smaller enterprises or normal developers like us, who have some things like managing documents and searching through it. So probably we all know that generative AI has disrupted every industries. So now every business is wanted to implement generative AI into their use cases. So for that, they need to manage somehow documents, the context to their knowledge bases regarding that business context. So that is somewhere stored, and it's probably in a documented way in a documents. So for that use cases, integration into the generative AI use cases through those documents is what we require a searching. Basically LLMs search through those tons of documents and give you the respective response to that. So this is somewhat regarding this solution, regarding that it's going to provide you a better way to search through documents, and it's an end-to-end server. Uh, what is this kind of application? So basically this is an API service. Now this API service is written in Python using fast API server framework, I would say. And the reason to choose that as a fast API framework, because it's light, fast, and it is kind of Python agnostic, because there are like tons of libraries written in Python, and that's why we chose fast API framework. And we chose Python because like tons and tons of libraries that could be useful and we could leverage in our project. Another thing is, we are going to provide a role-based access control with the API keys and JWT based token. And to manage those documents we need a object storage. So for now, I guess S3, I have AWS S3, I found it very cheaper and it's kind of very good. So we are using for file storages and for object management we are going to use S3. And for communication based we are going to use Q components. Let me share you the components of applications which are for object management. We are going to use S3. For Q communication we are going to use SQS. Still I have a free plan, so AWS is kind of generous, so they are providing 1 million kind of request via Q, so that's why it's very cheaper. That's why I consider Q. But in future use cases, if I'm going to be more open sourcing or maybe making it more cheaper, I would be using Redis Q. But just for MVP purposes we are using SQS. And for the very important part of this project, which is vector storage, where the actual vectors of those documents are going to store, and for that we are using Milvus standalone. So Milvus is itself a enterprise grade vector storage solution which is probably open source, and standalone is a kind of variant of that we could self-host it and use it. So that's going to make this project very cheaper, and it is going to make it open source. So for the database we have been using PostgreSQL, and because PostgreSQL I like it and it is very versatile for our use cases. Another thing which is that about vector storage is the reason to use Milvus was we wanted to make something cheaper, okay, but at the same time we wanted to integrate open source features also, and we wanted to have a great support, and we wanted to have advanced features. And Milvus has, it is kind of mixture of everything. It balances everything out. And so we could use their, as a developer, we could use their provided service via cloud, but we don't want it to do that. That's why we are using Milvus open source solution, and we are going to self-host it, and we are going to build regarding that. So these are all the introduction and basic components which I have shared about my application. Now let me show you the demo about certain things and certain angles about it. But the first thing first, we are going to talk about the document management. How is the document management occurring? So let me show you how the document management is done. So basically document management is needed to be asynchronous. Why the document management needed to be asynchronous? The reason for that is, if someone who wanted to leverage this system which I have built through front end, we are going to manage the scale through it. That's why the upload management was architected in a manner that it could handle the scale. So let me show you how is the management working. Upload management is working. So we are having a client. This is just a part of an application which I'm building, which I'm showing through the diagram. We have our API server, we have our database, we have our object storage S3, okay. So these are kind of 4 components just for what we are going to do is file upload management. That's what we are going to do. And so first request initially, what we are going to leverage is pre-signed URLs. Why the pre-signed URLs? Because pre-signed URLs is like kind of very use case. The pre-signed URLs use case is kind of very easy for and very scalable for front-end integrations. As in service to service communication, it's different game, and it's a different problem to solve. It's a problem for another way, but we have considered that front end would be integrated in that. So for those, we have to understand the scale and the simplicity of uploading the files and managing through the API server. So we thought pre-signed URLs would be right use case. And so the first step is client asks for request for pre-signed URLs. That's what the client requests for. Okay. The second step what API server do is, the way client requests, there is a certain way through that the API request is going to go, and using that certain way, we have certain entities, the schema to create an association or create a record in the database. So we have generated the pre-signed URLs, and at the same time we are creating pending records for those files. That's what we are doing. Okay. And kind of we are using a saga pattern, which I would come late, which I would share later about what we are doing once the whole diagram is completed. So this third step what we're going to do is we are going to generate the pre-signed URLs from AWS S3. We got that, and then we are going to provide those pre-signed URLs to client as a response. That's what we're going to do. And later client is directly going to upload objects to S3. Now here's the thing, for the security measure we have kept an expiry of that, and that's going to be 5 minutes, and because the documents are not expected to be large, we have considered a threshold. The threshold is maybe 50 MB or maybe 100 MB, and that's enough for a normal PDF file. Because we are dealing with smaller enterprises and developers, so I guess so that would be fine. So the thing here is that we are directly uploading to S3 via that. And another thing which I wanted to share was that considering the security measure about here, which is that we are not getting exposed from the dev tools or maybe from the browser if we are responding with those pre-signed URLs. What I wanted to say is that even those pre-signed URLs got exposed to the dev tools as we are responding via API server, only the authenticated person who are authenticated through our server can only request that. So that's how we are backing up our security, and that's how we are closing all the loops for vulnerability. So only thing, two things we are going to measure here for the security is that we are setting the expiry for the pre-signed URLs. At the same time, only the users which are authenticated to our server are able to send that pre-signed URLs, and which I earlier shared that via API keys and via JWT token we are going to authorize users. Okay, that's first thing. And via uploading objects to S3, that's what we have done. And once the uploading part is done by clients are going to send us success and failure status is of objects, and it has an association ID with that when they send that, and that's going to lead us to a final step where updating the status is of final records which were pending. That's what we're going to do, and that's what it does. And this is kind of a I wanted to bring an angle of a saga pattern where you have a multiple entities, multiple remote operations that are occurring, and you wanted to break it down in a manner such that those operations can't be wrapped in a single database transaction, because here we are maintaining state in our database, at the same time we are making a remote operations, and at the same time we are going to upload this document. So it's a long running thing, and at the same time we wanted to maintain the consistency. So how could we do that? We create those small records with an atomic transaction, and see the first atomic transaction occurs when we are creating a pending records in the file. That's the first atomic transaction, and we have that pending states. And the second step, we generate those pre-signed URLs and provide to client. That's the second atomic step. And the third atomic step is client is directly uploading to S3 and letting us know that those files are uploaded successfully, and some files are failed and those are not uploaded successfully. So that's the final step in the atomic transaction. This is not an working as a whole single transaction, but there are multi-step, and those are individual independent transaction, but as a whole they are trying to make the system consistent. And even though during failures, even though client didn't provide us the successes and failure of statuses, we have those pending records, and we have a separate cleanup process which is going in the background, and that's going to clean up those documents by researching back to S3 that this file record is pending, and we have these object keys, and we have this data. Does this object exist in this S3 or not? And if it does exist, it marks the status to the final state, and if it doesn't exist, it just delete that record. So this cleanup process, which is scheduled at a certain time, that's also take care of inconsistency. So with every dimension we have tried to solve this problem. So let me show you a demo how this is working. I have to start couple of things here. I'm starting my database. Another thing, I have to start my Milvus instances also. So we have started our Milvus instances, and we would wait some time because it's not loaded yet. So we let it be for certain amount of time we're going to wait, hardly 5 seconds. And okay, let's just start our application. So usually it's com- composed of multiple scripts, so we have a single script here. That's what we are going to run. And okay, so this has been started, our application has been started. Let's just test it out, the upload part which I've just shared you with a diagram. Okay. Wait, we just, it's an API service, so Postman is the manner through which we are going to search through the things that we are required. Okay, so this is all the endpoints which we have created here. Okay, so let's go to document management. I have already created my session here with all the environments which are required for the NeuroStash. You can see my users and API keys and all thing. Let's just, this is the first operation in my day, so maybe the previous token has been expired, so we are going to generate it again and use it. So it generates the token. Let's just set it. Once this is set, we are going to do an upload. Okay, so let's just say we wanted to upload a file with the name reference.pdf. Okay, so reference dummy reference, let's just do that. Okay, so we're going to receive this pre-signed URL. Okay, now there is a tooling, separate tooling which I have written for my use cases, which is like directly uploading via pre-signed URLs to S3. So which is not a part of a project, but it is just a separate tooling written for my use case only. So let me run it and just upload it to S3. Okay, and let me just upload that document which I wanted to upload. Copy it. Just for the tackling against the header mismatch, we are passing the content type also, so that we don't face any issue while uploading. So this has been successfully uploaded. So we have, like, instead of from a front end via client is uploading to S3, we are using our own S3 tooling to upload that file. We just justify what client would do, would upload directly to S3. So we have initialized it, but you won't find this documents yet listed in the database when we are going to list it. Okay, so see, you could find none documents present here because it's in pending state. So we only show the documents which are finalized, but still it hasn't been finalized. So this document has been done. So the ID for that was 1. So what we would do is we would mark it as 1, and let's just do it. So we have successfully finalized our document, and you could see this record has been shown that this file is present. So that's how we are doing document upload management. And in that case, let's say if some failure occur, okay, let's say we're uploading some reference, okay, we wanted to upload multiple files, so multiple pre-signed URLs would also be generated just to handle the scalability thing. So we are going to upload this second file, not the first file. Let's just copy the URL. Let's just upload it, and then upload is successful. Now somehow we are considering that the first got failed, we can't upload it, so we are going to finalize it in a manner that the idea of this second got failed and the third got successful. So this got failed, but the third one was successful. So we just did that. Let's just list it. So only the successful files would be listed. The ones which are failed, and there will be cleanup eventually. But that's because actually failed, and we are maintain the consistency state via uploading that. So that was the part of the upload section. This is how we are managing the upload, and this is how we are handling the scalability in terms of uploading, because uploading is kind of very important section for this.